Welcome back. I have news for you. I have decided to update the reconstruction of the marine fisheries catches of Olaland. Please note that the steps that I'm going to describe can be applied to any other maritime country or territory, as well as to periods different from the ones I will be updating. Also, a methodology based on the principles of marine catch reconstructions has been developed for reconstructing freshwater catches. However, such methods are not addressed in these videos. The Sea Around Us initiative has already reconstructed the marine fisheries catches of all maritime countries and territories. The initial reconstruction was done from 1950 to 2010, and subsequent updates to this reconstruction were extended to the near present. The Sea Around Us website, thus, will be my initial resource because it contains the most recent reconstruction that needs to be updated. The first thing I did was type www.seaaroundus.org on my browser, and then I clicked on the Tools and Data section. There, I searched for the exclusive economic zone of the country I'm going to be working on, in this case, Olaland. Once on the page, I read the original reconstruction reports and papers for Olaland. I paid special attention to the methods and sources originally used. After I became acquainted with the published information on Olaland, I emailed the Sea Around Us team. I asked them for the working files that contain the data used in the previous reconstructions. These will be the basis of my reconstruction update. Right away, I received access to a shared drive that includes several folders. The first folder is called Baseline Data. It contains Excel files extracted from available reference databases. The most important of these are the datasets extracted from the FAO and the Sea Around Us databases. These are compared to determine what might be major changes, notably retroactive changes, in the most recently reported statistics. Versions of time series data extracted from FAO's FishStatJ database of member country reported landings from 1950 and used in previous reconstruction updates are included along with the most recent time series of landings. The data on these spreadsheets were cleaned by a Sea Around Us research assistant with a custom script that removed unnecessary information and formatted the data in a way that makes it easier to work with. Another spreadsheet available in the Baseline Data subfolder is called Olaland Extraction. This shows the reported catch data downloaded from the Sea Around Us database used in the last reconstruction update. Since the EEZ of Olaland is in the faraway ocean, this folder also includes an Excel file with data reported by the Faraway Ocean Tuna Commission, or FOTC, which is meant to be used to determine the tuna and other large pelagic species caught inside and outside the country's EEZ. If your country's EEZ is in another ocean basin, this file will likely show data from a different regional fisheries management organization, or RFMO, such as the International Commission for the Conservation of Atlantic Tunas or the Inter-American Tropical Tuna Commission. Finally, the Sea Around Us also provided information about the access agreements between Olaland and other countries fishing in its exclusive economic zone. Access agreement information lets me know whether other countries are fishing within the Olaland exclusive economic zone, either legally, if there is an agreement, or illegally, if there isn't one. This info also shows the deals Olaland has signed to fish in neighboring countries' waters and, in some cases, whether our fleets are fishing in foreign waters without permits. These baseline datasets allow for the identification of retroactive changes made by the FAO within their datasets and determine tuna and tuna-like catches in this region reported to the RFMO. They also allow for comparisons with the most recent version of National Fisheries Statistics data. It is important to note that for marine catch reconstructions, I will only work with data on marine, brackish, and anadromous, catadromous fishes and invertebrates, unwanted discard-only taxa, taxa used for direct human consumption and the production of bait or fish meal and fish oil only, roe, shark fins, and shellfish meat, all converted to whole weight of individual taxa, including shell weight. I will exclude data on aquaculture, freshwater taxa, taxa for aquarium trade or curiosities, jewelry or decoration purposes, reptiles, marine mammals, plants or algae, corals, and the portion of catch and release fisheries where individuals survived. The second folder within the shared drive is called References. It includes the references and national statistics used for previous reconstruction updates, organized by year, as well as the papers and reports produced after the initial reconstruction was done and following subsequent reconstruction updates. Looking at these documents allowed me to better understand the original methods applied, notably the methods used to estimate catches by sector. In a subfolder called New References, I will upload the most recent information and data I find on the marine fisheries catches of Olaland. The third folder that I will be using to update the catch reconstruction for Olaland is a folder called Working Files and Notes. In the main Working Files and Notes folder, there are two important files: the most recent working file and the notes for this reconstruction update. The Notes file is a Word document that contains detailed documentation made by a See Around Us research assistant on relevant information from previous reconstructions and updates, including an analysis of the differences found between the FAO, RFMO, and See Around Us datasets and recommendations on next steps. The most recent working file is an Excel document with several tabs, where I found a table that compares FAO time series to FAO time series from 1950 to the years of the reporting cycles that correspond to See Around Us updates. This table also includes a column with the reported baseline data for each year extracted from the See Around Us database, and columns that highlight the change in numbers and in percentages between FAO data from one reporting year to the next. Finally, it includes columns that underscore the change in numbers and in percentages between the FAO time series reported in the last reporting cycle and See Around Us reported baseline data. This table allowed me to identify retroactive changes to the catch data that Olaland reported to the FAO. For some years, the difference was over 15%, which is considered excessive. The spreadsheet also contains tables that disaggregate the catch by year, species, and tonnage. These tables allow for comparing reported baselines extracted from both the FAO database in the respective reporting cycles and the See Around Us database. On these tables, the See Around Us research assistants have highlighted in bright colors whether the tonnage in the latest FAO dataset differs from the tonnage previously reported and the reported tonnage extracted from the See Around Us database. The highlighted rows, thus, identify retroactive changes applied to the data. On the working file spreadsheet, I'm adding the time series of catch by species and tonnage that I obtained from Olaland's government agency responsible for marine fisheries and the marine environment. Adding this information will allow me to determine whether amounts and species disaggregation differ between FAO and national data. Whichever is more detailed will end up becoming the baseline data of my reconstruction update. Normally, if both datasets pretty much match, people end up using the FAO dataset. However, in this case, species disaggregation is better in the national dataset, so I will use this one. For example, for long-tailed tuna, Tunnus tonghole, national data presents catches to the species level, whereas the FAO data only reports at the not elsewhere identified level, that is, marine species NEI. On video 3, I will provide more details on working with national baseline data. Finally, in the working file, I also found a table called Baseline Checks Layer 3, which focuses on tuna and other large pelagic species reported by the respective Regional Fisheries Management Organization, or RFMO. Data on these species include bycatch and discards. The See Around Us decided to estimate these catches separately because the RFMO data for tunas have greater spatial resolution when mapping compared to the FAO data. What this means is that every time I have industrial catches from outside the EEZ, I will need to exclude that portion of the catch from my reconstruction. If there are artisanal or industrial catches of tuna species inside the EEZ, then I will need to include a portion of the reported catch in the reconstructed data. On this baseline checks layer 3 table, there is a time series with catch amounts reported to the FOTC per species per year starting in the year Olaland began reporting to this regional fisheries management organization. These data are compared to the catch amounts for tuna and other large pelagic species reported by the FAO and to the catch amounts for these species in the sea around us reported baseline dataset. In the next video, I will show you how to organize the national data and find information to account for missing components. Keep watching.